Okay, welcome everybody to the I forget which session we're in. Let's see, we're there. So this must be the seventh session since we started with session 0. So today is value stream delivery, and Thursday is risk management, and we follow these chapters. And we have done these chapters here, 1 to 5, and an introductory. They are all recorded. Um, what's the status, Shiraz, on getting a hold of the recordings?
Yeah, all the recordings are published, and they're linked to from each of the meeting sites.
Right.
There's a link to the recording.
We talked about finding one
Yeah,
place to go to. Is that,
yeah. I'll publish it on the USWA channel.
please? Yeah.
Yeah,
Okay. But they are, so you have access to everything, in addition to which you have the texts.
yeah.
That's fine. Okay, so we have plenty to go through, so I'll go straight to section or chapter 6, if you like. There we go. And as you can see, we're only 1/3 of the way through the book, so there's plenty to learn. And there we go. Start of chapter 6. You can do the same or just follow on your screen here. Let's see. Sorry, I thought that would be it. Yeah, so we did prioritization last time. Good. Now, most of, I'm going to call this EVO, and EVO is short for evolutionary, but you can also call it evolutionary value optimization. Okay. But to put it in more familiar terms, for those who are familiar with Agile, it is an Agile method. In fact, it is usually cited as the first published Agile method, using books like this, Principles of Software Engineering Management from 1988, was chock full of EVO. And fortunately for me, when they wrote the Agile Manifesto, they did not call it EVO. They called it Agile, so we can distinguish. But it's essentially an Agile method, a step-by-step method for delivering value. And I'm sticking with the name EVO. Okay, let's see. Here's the concept of EVO, which I consider an ancient method and a simple method. And it's EVO is built into nature. That is, we use evolutionary methods to for our species to survive and our body to survive. And that is, we're always working towards long-term survival of us and our tribe, and maybe even our planet. And then we're also working towards success goals, like maybe getting more educated, which is what you're trying to do now, more happy, more wealthy, more healthy. And we are constantly adjusting our behavior. A great example of behavior adjustment is the way that the Norwegian government is managing COVID, which is really such a process to help us all survive. And they're constantly getting new data, getting feedback, learning, and making decisions and changing behavior, which is kind of disturbing. Wouldn't it be nice if there were just one rule for COVID and we didn't have to like wear a mask? But it isn't that simple, and maximum value delivery requires rapid and adjusting of behavior in many different areas. Okay, so that's what it's all about. Here's somebody. His name is Joseph Juran. He's one of the quality gurus that taught the Japanese quality, along with Dr. Deming, who's perhaps slightly more famous today. And he's also the editor of a thing called Quality Control Handbook. Here he has some picture of from Egyptian tombs showing measurement they're measuring pyramid blocks here, I think. And it shows how old some of these ideas of quality control are. That was his basic idea. So, the ideas I have are really parallel with the Deming and Juran idea. I call them the Evo cousins. And statistical process control and plan, do, study, act are the Deming ideas. Moving right along, here is Professor Peter Morris, who wrote a book called The Management of Projects. And one thing he figured out there, long story short, all projects that had feedback and learning were much more successful than projects that were big bang and waterfall. Today, we sort of take that for granted, but his book was published 1994, well before the Agile Manifesto, and it was based on research about what worked, and what worked was models that had lots of feedback and things like that. So refer you to that. Here's another person who's one of my heroes, but then I'm an old guy, Tom Peters. He was in his time with his the most popular management philosopher. What he did was he researched which companies were doing very well, and then he said, what do they do? And what he found was they did things in short increments, which he calls quick prototyping and quick wins and things like that. And he wrote several books which specialized in what we call short sprints today. So what I'm pointing out here is that in the management area, when was this book from? Year 2000, just before Agile Manifesto. It was well known by the leading management people that doing things in small sprints and getting feedback worked a lot better in business than other methods. And again, maybe nothing new for us today, but it was quite new. And I think Tom Peters still alive and well and on videos and things like that. He still is pushing those ideas of, if you like, small sprints. Chunk it up next 3 weeks to find a set of practical micro bits that can be subjected to real world tests. That sounds like exactly what I'm talking about here. I was just looking at a history program on television, and it basically said everything you ever wanted to know about modern agriculture was discovered hundreds and thousands of years earlier in China. So here's quite a famous philosopher, Tao Te Ching, forgive me pronunciation, but a good 2,500 years ago, with a lovely quotation, that which remains quiet is easy to handle. That which is not yet developed is easy to manage. That which is weak is easy to control. That which is still small is easy to direct. Deal with little troubles before they become big. Attend to little problems before they get out of hand. For the largest tree was once a sprout, the tallest tower started with the first brick, and the longest journey started with the first step. So this sounds very agile to me. I quoted it in my 1988 book, but it's worth reading all on its own. So you might say agile is an ancient Chinese wisdom, nothing new about it. We're very busy celebrating the 20th anniversary of the Agile Manifesto, but these guys were celebrating long time before that. They knew and understood it. Here is from my, let's see, these are illustrations from my competitive engineering book, and remind newbies that we are giving free digital copies of the book. And if you look in the references in the back and look for competitive engineering, you'll find that. But this is the standard or textbook for everything I'm teaching on this course. And we have a separate chapter on EVO there, which you can look up. So yeah, there's the reference CE, competitive engineering, in the back. But again, same thing as I pointed out in all those other things, it's working towards long-term survival, in short-term thinking success of our project, which could be an 8 to 16 year long Axon health project for the Norwegian government. And long-term survival, well, I guess medical survival of the Norwegian patient population, what we're working towards. And who knows, in 20 or 30 years, we might have one patient, one journal. And now, let's say this is long-term survival of the people in the medical system, and then Axon needs to get some success in what they, the functionality they cover and the security and privacy of the system. And let's call these success goals. And we need to constantly adjust behavior step by step to the environment, which is constantly changing. Big environmental changes, the COVID crisis in the middle of everything, disturbing all normal medical activity, and getting feedback that you're on track, okay? So here's another illustration from the competitive engineering book of EVO, immediately a lot more complex, but the head is your long-term plans, long-term goals, and the body are what we would call sprints. But the sprint is divided into a development cycle, a production cycle, and a delivery cycle. We're going to talk about concepts like backroom and front room, or a few pages down here. But so a little bit more complex, but lots and lots of feedback. But the head has the brains and the vision, and the body carries out the actions of delivery. And so that's one way of looking at the whole thing there. Let's see, make that a little smaller. So here, describe EVO as a set of ideas. So first, there's frequent delivery of system changes. Now, and we call these evolutionary steps, or evolutionary value delivery steps. So notice it doesn't say frequent delivery of code or of user stories. We don't think that's important at all. In fact, you can make changes to systems without writing any code or delivering any user stories. And but now frequent, in very simple terms, I'm looking normally to a frequency of about every week. But in some cases, like 8-year projects, I'd be quite happy to deliver every month or every quarter. Roughly, we're looking at delivering 2% of the budget, 2% of the time to deadline. In other words, 1/50th of the project at a time is our notion of what is frequent or small delivery. So we quite consciously decompose, and that was last Tuesday's session on decomposition, but we decompose until we have steps that are somewhere between a week and maybe 2% of everything. Now, by the way, the word system is saying it's not just about IT. In fact, you might use these methods and have no IT whatsoever. You might be building apartments or something like that. And of course, architecture has the problem that even if it is IT architecture, you have to deal with all the hardware and the data and the people and the culture. So architecture immediately demands that you think in terms of systems architecture, not code architecture. And there is far too much focus on code and coding in the agile that is currently most popular. Now, these steps are delivered to not customers and not users, again, which is the too narrow focus of the popular agile, talks about the primary purpose is delivering working code to users and customers. No, we deliver to stakeholders. And what are stakeholders? Well, they are users and customers and maybe 50 different types of other things. For example, they could be delivering to the European Union GDPR laws on privacy regulations. In other words, it could be delivering increased or enhanced privacy. And the GDPR is not a user and it is not a customer, but it is definitely a stakeholder, as we learned with the Smittestopp programs for COVID tracing in Norway, which the failure to understand that GDPR was a stakeholder led to total failure of the whole initial project last year. So we're delivering to stakeholders, and I did a separate session, number 1, on stakeholders. So if you're just joining in, you might like to look back at that. But stakeholders are quite simply all the entities that have requirements that we must respect. So in other words, where the delivery step delivers in order to satisfy requirements. Quite simple. Okay. And then we get feedback from stakeholders. For example, we had a gang of stakeholders, a gang of IT people, like Johannes Brodvall and Simon Sommerfeld in Norway, who said, wait a minute, the government is collecting too much data and it's against the law. And so who were these stakeholders? Well, citizens concerned that we did things ethically was a stakeholder. And they had the power, not least their technical knowledge. They got together a gang of about 60 people and started sending messages to the government saying, do you realize that this Smittestopp program is violating the law to which we are committed, and it's not ethical either. And the government finally agreed with them. So some of the stakeholders you have to satisfy are people who are ethically interested that Norway does the right and honorable thing, for example, by respecting privacy and respecting laws. Now here's something almost strange. I always make the assumption that I'm going to use, for the initial steps, the old system, even if it is not an IT system, no matter how old and no matter how bad it is. I'm always going to use the old system. And I'm going to deliver increments until it becomes the new system. But I'm going to get some value, some improvement step by step at every step. And the only way to do that is to avoid constructing a whole new system and using 8 years and 22 billion kroner as suggested by PwC to the Norwegian government for Axon. We're not going to build it. We don't build. This is not about building new systems. This is about delivering value as soon as possible and cumulatively, incrementally, if you like, delivering value until all the value we want is delivered, in which case you by definition have the new system. And somewhere along the way, you might end up swapping some hardware and some software and some data structures and all kinds of things, but you don't start by building a new system for 8 years for 22 billion kroner. You start by every month, for example, delivering improvements to the health system as it is. And that, I was talking with a international friend of mine, an agile expert last night, and I said, if I could make one law in the country, it would be that all large projects, especially government-funded ones, had to deliver value measurably, step by step, in approximately 2% steps, no excuses. That mentality, that idea is simply not there. We're constantly building new systems from scratch. You know, when you're talking 8 years, you're talking Big Bang. Of course, we see that they're now transitioning to smaller and smaller increments, but I suspect not small enough. But they realized that the 8 years is ridiculous. It took them 8 years of preliminary studies to get to that point, I should add. It's really funny. Anyway, so Evo always starts with the existing system. Now that gives you a tremendous advantage. You have a working system and you can focus on the highest priority changes to give the greatest pleasure to the nurses and doctors in the shortest term at the lowest cost. And you can get real feedback from real systems. So if you're doing bad architecture, you will learn that you're doing it very quickly, not after 8 years. Okay. So, so the fifth point that about how small the steps are, I've talked about that. Here I've hinted at this, but let's make it more explicit. We don't just do any steps. We decompose and we analyze the value and cost of each of the decomposed steps. Let's say we have 100 possible steps, okay, after decomposition. And we then pick the ones with the highest profitability or the highest efficiency. I've been talking about this earlier. In other words, the highest value for the lowest cost. Doesn't that sound like a good idea? And we deliver the ones with the highest projected or estimated value and cost first. Why not? Wouldn't it be silly if we picked the ones with the lowest value and the highest cost first? That would be not very smart. So we have a slightly smarter principle that says we will deliver the ones with the highest value. And we're talking numeric estimation of a set of values, as I've spoken about earlier, not just one, and numeric estimation of a set of costs, both short-term, long-term, money, people, time. And on that basis, we prioritize the delivery. Again, we've talked about this mechanism in earlier lectures, okay? Now, the eighth basic idea here is that we get feedback. That means part of the feedback could be like from the IT gang who said, this is unethical for privacy and it's against Norwegian law. And this is just a group that constitutes itself out of nowhere. They didn't officially exist when the project was started, but they were concerned citizens which had technical competence, and they fought for their rights to have the privacy laws respected, and they won, okay? So that's immediate feedback. In this case, they'd already built the entire system in a big hurry, the initial Smittestopp, and so throw away the system and start again. Kind of silly. If we'd gotten feedback by earlier, we might have been able to modify the problem at a much earlier stage, and maybe months earlier would have had a COVID tracing mobile telephone app tool ready. But because they effectively did Big Bang, we lost about 8 months. Okay, instead of being the first to deliver something, we become among the last. Okay. Now, you might say, well, wait a minute, Tom, why are you talking about a delivery or project management process? Isn't this an architecture course, right? In which case we should stop. We're done with the architecture course. We should be talking to project managers, which I seem to be doing. And the reason I've hinted at it earlier, we believe that the architect needs to be there for every step, reading the feedback. And if we get bad feedback, the architect needs to adjust the architecture immediately. In other words, there is an architecture moment at every sprint, if you like, every Evo step. And this method was used with great results in the IBM Cleanroom method that you'll find reference to in detail in the references at the end. And I've hinted at it earlier, where the architect, every step, looked at the feedback about costs, feedback about values, and if they got bad feedback, unexpectedly bad feedback, the architect jumped in, modifies the architect, and then they try out the architect in a future step, not necessarily the very next one. But they get rid, in other words, we're getting rid of bad architecture continuously. Okay, this is agile architecture, and most architecture methods don't have that idea that the architect is in there in the middle of the steps, because most earlier architecture methods are Big Bang rather than agile. So the feedback, step 9 here, we decide, we decide for the next steps, really, not necessarily the very next step, what to do. And the rule is change anything that helps. In other words, throw away any architecture that's not working well enough and replace it with architecture that we hope will work well enough, and validate with feedback that it indeed does act as expected. And if not, throw it out until you get it right. Okay. So, and to sum it all up, the orientation of the EVO method is results oriented. And the results we're talking about are primarily values, which are primarily qualities like security and privacy, but the results can also include functionality and keeping control of costs. Okay, so in other words, all kinds of requirements define what we mean by results. Although the primary thing we're doing is delivering value enhancement. In general, the functionality we want tends to be there, even though it's not automated. Okay. And so we don't have to rebuild all functionality from scratch. It's already there. And the system is basically working, but not well enough. We need to improve it. So the focus in all projects that I've seen is enhancing the values. In other words, making reliability better, technical debt lower, usability better, many of these qualities we talk about in the books. So that's the, if you like, overview of the method. Here, I talked about this earlier, but this is, if you like, explaining and defending the idea of using the old system as a base, okay? And I don't think we talk about that enough. In fact, there's a lot of pressure to build a new system, and the pressure comes from suppliers who'd like to supply all the new hardware and software and services and build a new system. And usually the customer is too weak to realize that they have an option of modifying the old system until it gets better. And so, and they believe that all, that these suppliers are telling them good advice. There are all kinds of excuses of why we cannot use the old system. But I found for decades that that is never true. You can always use the old system, and it's always a smarter way of getting quick results and accumulating results. It's the smartest way of doing agile. Anyway, so I've practiced this since 1960 without any known exception. It works. But if you want more detail, you might like to read this. I'm sure that some of you are having a hard time with the idea of starting with the old system. And I know that there are 20 reasons why it can't be done, all of which are not true, but you need somebody to maybe explain to you where the reasons are not true. I'll make a bet with anybody for a lot of money that the reasons you have for not using the old system are false. You put your money on the table and you'll lose it and I'll win it. Try me out. Most people chicken out and go down to a $1 bet. So they don't lose too much money and they do find out, but I'll make you a bet. I've written a lot about this in various books where a lot of very intelligent, well-educated people like you sincerely believe they cannot use the old system as a base, and within same day of thinking about it, They admit to me that they are wrong, that they can use the old system, and they should. So maybe you ought to start studying this idea. It certainly is a major architectural idea, isn't it? That we're going to use the old system to start with rather than building a completely new one. So this is major architecture ideas. Here's a little case study from Philips of Holland, a gang that was there. What they were doing was had automated putting components onto boards and have manufacturing. They made the machine that did that for anybody who wanted to manufacture boards with electronics on them. And they had a program which predicted how long the run would take to manufacture things. And their program was very inaccurate, basically. It gave results worse than plus minus 30%. And they'd been struggling with this, and I happened to be working with them. And I said, we should be able to deliver improved accuracy of the estimation program week by week. And everybody at Philips, all smart people, said that can't be done. And but Frank, who was the manager, said, well, I'm quite desperate, so maybe it can't be done, but you seem to think you know how to do it, Tom, so I will listen to you, and I will follow your ideas, and we'll see what happens. So Frank did, and here is a report. We got actual delivery in the 8th week. I think these people had been working over a year going nowhere, okay? But in the 8th week, we started delivering a degree of, one of the test cases was in this range, -10 to +20, and 5 of them were this. So this is number of test cases. And then as the weeks went on, we were delivering one value that they wanted, which was accuracy of deciding how long the factory run would be. And as you see, it took a few weeks, about 10 weeks here, but they were able to substantially improve the accuracy of what they did. And Frank went into his group. I wasn't there, but I heard that when he presented his results, he got a huge round of applause, including from his boss, the director, who in a meeting with me had said, this is not possible. So what I'm just showing you is one of maybe 100 examples I have of smart people who said it's not possible to deliver value to the old system week by week, and the fact that we simply did it, okay? And Frank will tell you that himself. Okay, so there we go. And I have a very large number of case studies. They're scattered throughout any of the books I've referenced, and you'll find, how did this get done in practice? Okay. Okay, so values, yeah. So now here are a list of reasons that people think they cannot do this step-by-step delivery to the old systems, and I'll look at these a little bit, but if you like, what I've done is I've just made notes of all the reasons people gave me that were untrue and tried to explain why they were untrue. So this, with reference to case studies, here's Confirm It in Oslo as a case study, for example. And but let's take a little look at it. Why are people saying that can't be done? So they're afraid that they have an old system with huge amounts of technical debt, and they don't want to touch it because they're afraid it'll bomb out. That's a reasonable fear. Okay, but for example, the value you could start delivering was in fact the stability of the system. Okay, so that it didn't bomb out when you put in a little change. And Confirm It in Oslo, a Norwegian group, did exactly this. They reduced their technical debt using 1 week every month, just focusing on reduction of technical debt, which was, and this was quantified as a set of about 10 values, including like how fast they could test a change to the system afterwards and things like that. The details are published in this reference. So here's a Norwegian group who did it once a month, every month. And then the other 3 weeks of the month, they delivered user-oriented values. But 1 week a month, they delivered the value of their own system having lower and lower technical debt. I know many of you are interested in how to treat technical debt. And here we have a great case study of using my methods for iteratively reducing the technical debt of an 8-year-old awful system that was very difficult to maintain. Okay. Here's another problem that everybody who knew the programming languages used, let's just say it's COBOL or something like that, has left the company, so nobody is qualified to touch the older systems. And but it turns out that with the right pay and conditions and training, anybody can learn anything and they will do it. But they might not be Norwegians, but they'll do it. So this is just not true. Let's see. Here's another problem that that I've tried to deal with in teaching this course. Architects have no competence in analyzing and specifying quantified stakeholder value requirements. So they don't know how to think about doing things in now. So partly I've talked a bit about it, and chapters, I think from 10 and onwards, talk in even more detail about quantifying these values. So basically, yes, your architects have not learned to do it. They're quite astounded when they learn that things like security and usability can be quantified. But I think all architects need to be trained and master the art of quantifying all stakeholder values without any exception. Okay, so if you want to teach yourself, go to I think it's chapter 10 in this book, and there are several references, and learn it, and maybe we'll hold some lectures on it too. So again, retrain or remove. This is so vital for architects that they can understand the values that the stakeholders want. So if you can't retrain them to do it, I'd say remove them. They're useless as architects. Goodbye, you lose your job, and hire somebody who will train to do it and will deliver the values that the stakeholders prioritize. Okay, so architects who can't do this are seriously incompetent to deal with anything. Okay. And enough of that. So let's see. There's more here, but I would consume, I've only got 19 minutes left and lots of other nice things to do. So what I've tried to do is write down things I hope you'll feel that, yeah, we have that problem too. And say, okay, well, here's my answer. And my answer often refers to, additional free literature that will help you deal with it. And if somebody wants to make me a heavy bet, let's say 100,000 kroner, real money, I'll explain how to deliver the Norwegian health systems this way. Okay. Okay. Here's another case study. And again, timing says I shouldn't get into it, but it's kind of fun. This is the British Navy. It's a radar system to the British Navy. And they were thinking big bang, like we're going to put a radar system with 3D, 2 eyes, 2 radar systems on a ship. And we have to wait until the ship is delivered X years. And so there is no increment. And I was talking to the chief of the research labs in Britain. He came on one of my courses, and I explained to him that they could deliver incrementally by incrementally building their database over different types of enemy planes and friendly planes and their signature. And they could, building the database, if you like, airplane by airplane and ship by ship, they could increment the system's ability to detect enemies and friends at any time, and maybe right in the middle of it here, the big ship got delivered, so they had this capability, and then they could continue incrementing the capability from whenever the ship was made available. In fact, we said that before the new ship was made available, we could do this on old, real ships, real existing naval ships. You can read about that, but that's an example of a case study where the chief of the development lab obviously must have been a smart guy to be chief of a weapons development lab. He said, I don't think your ideas will work. And I spent my lunchtime solving this problem with him and got his acknowledgement that you're absolutely right. I think there's a quotation here that I kind of like, where he said, somewhere, he said, you know, the thing that most amazes me, Tom, is that nobody of my smart engineers has ever thought thoughts like this. So they must be quite radical, but they're as old as 2,500 years old Chinese thoughts too. Okay, so now here's the evolutionary process. So this is undoubtedly from the competitive engineering book, from the Agile chapter, which is chapter, there we go, page 300, etc. So you all have you have a digital copy of this if you want it. But so this is the process description. Okay, now I'm not going to go through it in detail, but you can use this as, if you like, your standard for how to do things. And but let me, here's another view of it in our EVO cycle, if you like. Let's start here, and this follows the course. You know, identify your critical stakeholders and identify all of them, not just your users and customers. Identify their critical values, like what is legal or illegal would be a critical value in Norway. And identify by definition, the values are things you want to improve in the future. So you need to quantify these values and say how much improvement you want numerically, at what date, by what deadline, okay? And then you need to do your architecture, which means find the architecture or solutions, and you need to decompose them, which we talked about 2 courses ago. And then you need to develop the decomposed architectures, and you need to prioritize which ones you're going to do in the short term, and that's what you deliver. You deliver the things you prioritize next week, and then next week after that. Then you deliver to a real system, and you can measure how real stakeholders really react, not theory, not testing, but measurement of real change to real, for example, Norwegian health systems. And then you measure, you know, how far did we deliver the value? What did it really cost? And you learn, oops, this wonderful architecture idea wasn't such a good idea anyway. Let's change it now, not wait until the end of an 8-year period of building Axon. That's silly. And you continue the cycle. So in a nutshell, EVO is this cycle. And this is a way of you know, writing it down as a process to be followed. And these diagrams give you more information, but we don't. We only have a quarter of an hour left, so we're going to do more fun things as we wind down here. Here's a man who wrote the Systems Bible, John Gall, no longer with us, but I did have the pleasure of inviting him to my Gilbfest in London with his wife, and he made the following statement, which I like to quote: a complex system that works, think of Norwegian medical systems, is invariably found to have evolved from a simple system that worked. Got it? Exactly what I've been talking about. The inverse proposition also appears to be true. A complex system designed from scratch, like Axon 8 years, 22 billion kroner, never works and cannot be made to work. You have to start over, Smith is stop 2, beginning with a working simple system. And that's exactly what they did, right? They took the software which is already out there, instead of saying, we will invent it in Norway from scratch, and they use a simple working system. So Gall stated this law long before Norwegians started screwing up their government projects. And it completely is what I'm talking about here. This is just, this is the same thing that Tom Peters observed in business, and the Chinese have observed. And when will we ever learn, as John Lennon said? Okay. Okay, 11 minutes left. How much planning do we have to do up front? Well, I believe in what I call my Evo startup process, okay, which is quite simply a week of planning, okay? And then after that first week, I start delivering value to the real existing system, delivering increments, okay? In other words, I've time boxed it. The planning, even for very, very large systems, takes a week, okay? I'll give you an example. I worked a long time for Boeing Aircraft, and we had 25 aircraft projects, and all of them used the week of planning before they started delivering increments to the aircrafts, okay? In other words, it works anywhere on anything, anytime, and I've been doing it for about 50 or 60 years, okay? So the idea that, for example, PwC used, was it about maybe I could be wrong, but quite a few million kroner and 8 years to plan Axon. That is completely ridiculous. It should be illegal. I believe that Axon could be planned in a week or a month and start delivering thereafter, maybe every week or month. And if people don't believe it, I'll make you a bet. I'll help to show you how to do it. Nobody's ever asked. Here is, I've shown this diagram earlier. Here's a little development cycle, but so this is, you know, build it and deliver it. But these cycles, and here is the initial maybe week, just trying to say who are our stakeholders and what is our product vision and what is the architecture. And then here is detailed feedback from every step to the big plan, okay? Here is an example of doing it. This is a US Department of Defense in Washington, DC, on a very large failed project that didn't work in the Iraqi war. And here's what we did. Monday, we defined the top 10 critical objectives. Tuesday, we defined the architecture. Wednesday, we have an impact estimation table, which looks at how good the architecture is in relation to the values and costs. Thursday, we decompose it so we get something we can do next week. And now we know what we're going to do next week. And Friday, we presented the plans to the general, who said, I love it, best planning method I've ever seen, go do it, okay? So that's another case study of, by the way, this is the complete opposite to everything done in Washington, DC at the time, which was all Big Bang. And they were beginning to flirt with what they called evolutionary methods too in the late 90s. But this was, you know, the systems that we were looking at had been built Big Bang, and the plan was to do another 8 years of Big Bang. But the problem there is that the new war can start next week. So wouldn't it be nice to do as much improvement as you can week by week with a prioritized good values, rather than wait 8 years and discover you need another 8 years to complete it. In the meantime, your country's been taken over by the enemy. Okay. What I found is top generals love these methods. They understand right away the power of them. Okay. Here is, in fact, the impact estimation table for the US Department of Defense with the values, which they quantified on the first day, the architectural ideas they identified on the second day, the costs, the value to cost ratio, and beginning to circle in fact, this fellow here as a subset that could be delivered early, which we indeed achieved without going into more detail. Okay. Something called backroom, front room, and gee, I've got 8 minutes left. So I think what I'll do is I'll tell you, here's backroom, front room as taken into use at Philips in Holland. But long story short, every once in a while you find an architectural idea that cannot really be decomposed. Like it will require 10 weeks delivery time, and there's no way around that. So what we do is we don't try to force it. We put it in the back room and say, we will just wait until the 10 weeks are up, and then we will deliver it as maybe the 10th week, okay? So the back room solves the problem that some things are not strictly decomposable. What we said, we didn't say absolutely everything can be decomposed. What we said was we can decompose into weekly value delivery steps. We didn't say all the components of the system themselves could be decomposed into things that could be done or constructed or delivered in a week, okay? This is a real breakthrough idea because it solves the problem of when you can't decompose the components, at least you can decompose the value delivery and get going with something that does not require you to spend 10 weeks. And then later, you take that thing that took more time and you deliver it. But what you do is you create a value stream and you start getting results and you start getting feedback, even if some things are just not ready for delivery yet. There's an analogy here is what happens in kitchens is they prepare certain things like desserts, frozen desserts or whatever, and they can deliver them instantaneously to the hungry restaurant guest who has only 5 minutes to wait for the dessert. It's actually the same analogy. Here's some wonderful little quotes. The shortest way to do many things is to do only one thing at once. Nothing is particularly hard if you divide it into small cycles. Henry Ford. Here's some lovely poetry. Little drops of water, little grains of sand, make the mighty ocean and the pleasant land. I think that's a description of my method. And finally, one of my favorite artists, my wife's definitely favorite artist, she's a sunflower seed painter. Great things are not done by impulse, but by think Big Bang here, but by a series of small things brought together. Vincent van Gogh. Okay. So I used to hold courses, 1 week courses in Holland, and I used to, in the lunch break, take my entire class to the Van Gogh Museum. That's what I did on my high-tech courses. Okay, here's some information about, now we're getting to the last 3 minutes, so I don't really have time to do anything except here's all this nice stuff you can read about. Not least, a good summary would be the Evo principles. These are the basic principles of Evo. Just take one of them. The principle of strike early while the iron is still hot. Install small steps quickly with stakeholders who are most interested and motivated, the early adopters. But here are 10 fundamental principles of Evo. But nobody says it better than Da Vinci. And looking at his basic principles, if you start reading the principles, you'll discover they're agile principles. So maybe Leonardo da Vinci was the first serious agile guy. I mean, look, grace, ambidextry, fitness, and poise, that's directly agile. There's me visiting his birthplace, okay? And here's more agile ideas like getting feedback and learning from reality, the old system. Leonardo da Vinci said it, okay? And more Leonardo da Vinci. Here's failed steps, so what, push on. And greatest genius of all time thought that my Evo method was a good idea. Who knows? Was I reborn? Probably not, but be nice to think about. And so here is a survey done by the management, the Gartner Group. And here's all the agile stuff, but you will notice at the root, my evolutionary value delivery EVO method. Okay, at the root. Okay, so I'm the grandfather and love to brag about it. And other people officially recognize that what I'm talking about, by the way, and some people say this is still more advanced than a lot of, almost all of this stuff. Okay, so leave you to decide that on your own. And of course, you don't need EVO for everything. If it's dead simple and no problems, no risks, no complexity, no size, you don't need my method. Okay, so one more minute. Let me just point out that part 7 is going to be about a very interesting subject called risk and risk management. So you can read ahead on it, but that's this Thursday at 4 o'clock. Welcome. And gee, I'm done on time. So I'm gonna stop. I'll leave you with something like Leonardo da Vinci's principles of Agile, and it's question, discussion, objection, whatever time. And let me get the, let's see, I guess I want to see people here. So who would like to ask the first question or make the first remark or share the first insight? Don't be shy, there's plenty of space here. Somebody's trying to talk, but I think it's just background noise. So. Okay.
Hello, Tom. I have a question. My experience with the stakeholder has been that to plan, they want end dates of the projects, or even if we are planning to deliver value consistently, they want some milestones, big milestone, major milestones, which might be off initially. So how do you manage their expectation in this aspect?
Okay. Now, the whole art of quantifying the values, and again, I've talked about a little bit earlier, showed you some samples, but there is a whole detailed chapter on it. I think it's chapter 10 at the end there. It says something about, how to quantify the values. So you need to quantify people's long-term expectation, like when when they will be completely satisfied. To take a simple example now, let's say we're dealing with security, and we found that we have only 5% probability of detecting a hacker. So we'll set an expectation. Would you like to go to 10%? They said, you're joking. Okay, would you like to go to 50%? They said, you're joking. Where do you want to go? Well, we'd love 100% chance for probability of detecting a hacker. I said, well, you know what? You can't get it because it would cost infinite money and time, and nobody knows how to do it. I refer you to the United States government that just got hacked by probably the Russians. They can't do it. But what about a large number like 99% probability of detecting a hacker within 5 seconds? Okay, is that doable? Maybe. It's very ambitious, but we can talk about it. When would you like it? And they'll say yesterday. Well, no, when would you really like it? We're thinking that this is so ambitious, it will take us a year or two. Okay, if you can do it within a year or two, we're happy with that. So now we have 99% probability of detecting a hacker to be delivered within 2 years. That's setting their long-term expectation. They've agreed to wait 2 years. They've agreed to pay for it. They've agreed that they'll be very happy if they get there. It sure beats 5%. Okay, now, in the meantime, you say, you know, you're not going to, with the method that we learned from Tom Guild, you're not going to have to wait 2 years, and you're not going to experience that after 2 years, we're going to tell you we need another 2 years before you get anything. Okay, we are going to deliver the strongest, most effective security as soon as possible in small increments. And we've already worked this out. So we think that within the first quarter, we'll get to 30%. The second quarter, we'll get to 40%. The third quarter, we'll get to 50%, and so on. And we'll work our way up to it. So you will have tremendous improvements in the short term. And you can expect to get those improvements. That's a second expectation, is what's going to happen in the short term. And then they can track and follow this. The first quarter goes by and nothing has happened. They say, hey, didn't you say we'd get to 30% and we could test and measure we're there? And we say, yes, but our architecture didn't work, but we've modified the architecture and now we'll get 30% in the next month. Okay, so next month goes by and nothing happens. And they say, we thought we'd get 30% at least in the next quarter. And they say, yes, but the architecture didn't work. At this point, they might say, who's the stupid architect you've got advising you who doesn't know what he's doing, but he thinks he does because he says he's going to get 30% within a month. Can you find me some security architect who really understands architecture well enough to carry out a simple promise? Am I sort of answering your question, Yagam?
Yes, Tom. So follow-up question. You said that suppose first architecture didn't work. So we are revising all their plans and all their expectations at that moment.
Sorry, first architecture doesn't work, and then
we would be revising long-term expectation as well with that.
Not necessarily, not at all. In general, and this is our experience, for example, at Confirmit, when they set long-term expectations, which was 12 weeks away, a quarter of a year with release of their product to the world, they almost always achieved all of their 25 long-term expectations quarter after quarter after quarter. So in other words, what is actually going to be adjusted is the rate or speed with which you deliver the short-term increments. Okay, but we don't, just because we have a problem in the first week or second week, we don't give up on delivering what we're going to release to the customers in 12 weeks. They never gave up. What they did is they prioritized and made very rapid adjustments and tested them out very early. So in general, they reached, we have the documentation published, by the way. Look at the Confirmit case studies in your references. And they generally reached or exceeded 25 different values that they simultaneously work towards with a team of 16 people. So the answer is we do. Now, there could be 1 out of 25 where we only reach 95% of what we wanted by the quarter of a year. But in general, the next quarter, they would have cracked that one too. In other words, there was no history of large or even small failure of anything, even when they're simultaneously managing 25 values with only 16 people in a quarter of a year as their long term. Does that sort of answer your question? The answer is, we do not expect to fail delivering our long-term values. We expect the architect to adjust so quickly and so effectively, if necessary, by finding an architect that knows what they're doing for a change. I mean, how many times you accept that an architect plugs in a change and it doesn't work? Once, twice, 3 times. In America, 3 strikes, you're out. You don't know what you're doing, find a replacement architect. You got 3 chances. You get an answer to your question, Jörgen?
Yes.
Hopefully. Okay. Next question or remark or reference to other methods or ideas?
Maybe just fill in one while other people are thinking of a question.
Go ahead.
You know what happens sometimes is say you get a request for quotation from it's typical public sector in Norway.
Yeah.
It's a 200-page document with 1,000 user stories, and they want an estimates of the price that shouldn't be more than 20% out.
Mm-hmm. Right.
Yeah. How do you then use this method? Say you wanted to use this method, yeah, but then how do you price the proposal? How do you write the proposal in a way that this method can then be used?
Okay. Now, of course, the whole way of doing things is Big Bang waterfall. It's stupid and the government shouldn't do it. But right now they don't know that. They're too stupid. Okay. So let's accept the situation and answer your question. Now let me point you directly to the IBM clean room method, which is in your references. And okay, so they had exactly this problem. They had government contracting. IBM had accepted given a bid on a fixed price, fixed deadline contract for example, space shuttle ground systems, okay, or a naval ship system. And they also had fixed values, very high qualities, like 99.98% availability was a typical thing for their aircraft things. Okay, so they had, and we're dealing with high-tech technology that's like new computers from IBM that have never been on the market before, almost specially built for the military. So very high risk, very complex. You will see that they reported that in a 4-year period, every project was delivered on time, under budget. So whatever they did, they cracked it, that's for sure. But in the literature, which I've given you and if you need any help finding it, let me know. But if you just go to the references, look for IBM Clean Room, Mills, Dyer, Quinnen, you get it from the horse's mouth exactly how IBM cracked it. I also published this in my 1988 book, Principles of Software Engineering Management. But what they did was exactly the methods I'm talking about. They were using Evo.
Sorry, I'm having trouble hearing you.
And what they did was they have this architect guy called Robert Quinnen. And I've met and I've worked with these guys, by the way. And Robert Quinnen's job after doing the initial architecture is exactly what I said. They typically do about, for example, they had a 4-year project called the LAMPS project, which they delivered in monthly increments. So that's 2% increments, 2% of the project. After every increment, they looked at the cost, like did the 1-month increment take 1 month? Okay. Now let's just say, for the sake of argument, it took 3 months to deliver what they thought they would deliver in 1 month. So we now know that the architecture is costing 3 times more than it should, and the deadline is threatened. And there are severe penalties for exceeding the deadline, financial penalties. Okay, so the architect comes in and says, I must replace the architecture that costs 3 months with an architecture that costs only 1 month. And I need to replace it now, and I need to try it out ASAP and make sure it only takes 1 month. This is known as design to cost. Google it. It's a very well-known engineering tactic, and all architects should be trained to design their architecture so that it fits the deadline and budget for the project and the customer. Okay, and we talk too little about it. Design to cost doesn't appear in any of the other enterprise architecture methods that I know about. Prove me wrong. Okay, but what I'm talking about here is not the traditional engineering design to cost. It's dynamic design to cost. Dynamic means every one of the 50 steps, the architect may be called upon to design something cheaper and faster, because we've just discovered that it's costing too much in money, time, or any other resource. And this is not a job to be solved by coders or programmers. It is a design decision, and the design has to be made at the architectural level. So really, it's quite thrilling and interesting task for the architect to say, okay, we all thought this architecture was fine, but I have to find parallel architecture, meaning it does the same stuff. It delivers the same value of, say, security, but it's 3 times cheaper. Okay, and there's no talk of this idea anywhere in any of the enterprise architecture methods that I know about. Please correct me if I'm wrong, but they were doing this decades ago at IBM Federal Systems Division quite successfully in the face of lowest bidder wins the contract, fixed price, and you run over, it's at your expense, and highest complexity and quality of any systems. And they succeeded year after year after year. This is the method we all should be using to do architecture and delivery of software systems. They were, by the way, doing the software part of the system, I should add. And IBM may have been doing the hardware, but somebody else like Raytheon might have been doing the hardware. Okay, so long story short, what I'm talking about has been proven decades ago, and referring to IBM, and in all of my own customer case study projects, some of which I've shown you, and all of which are written up in the various books that I'm giving you for free, etc. So that's my answer. It's proven. Microphone is not on for Shiraz, but it was his question, right?
Yeah, thanks. I just had a bit of problems with my my audio.
Did you were you able to sort of get roughly what my answer is?
Yeah.
Clean room?
Yeah. So
Forget
it's very
Guild,
clear.
but clean room was doing exactly what I'm teaching.
Mm,
Exactly.
yeah.
And I was
Yeah.
working with them at the time. They were, Harlan Mills, who led the whole thing, wrote me a letter regarding my software metrics book. And he said, this is such good stuff. Why isn't everybody doing it? This book came out in 1976. Okay. We're still trying to get the message across that maybe you should quantify your values like security. And that's the basis for good architecture. We're still trying to get the message across to people who don't understand or believe in quantification of critical stakeholder values.
Mm.
And unfortunately, that's most of the enterprise architecture we see out there. They talk about values, and you take a look, where is it quantified? And you don't find it at all. So they don't have a clue. In other words, they don't. The enterprise architecture is not based on an engineering or real architecture paradigm. Architecture, real architecture, is just a branch of engineering. The enterprise architecture is just a branch of programming and craft. I hope somebody's getting angry and wants to debate this. But you got to debate with facts and examples and case studies, and that's what I do. And experience of what works.
But do you know? Do you have any idea why it is not more not been adopted adopted more?
It's got nothing to do with architecture. It's got to do with the rate of change of IT. Let's just say that there was a point where many of the bad old habits we have would be sufficient for the small scale and complexity we were dealing with. Okay. And but we're suddenly getting this explosive growth in hardware, permitting explosive, and I'm talking about memory and cost of memory and size of memory and size of computers. And you know, where you know my Apple Watch has more than was the computers had that were used to land on the moon, right? So we have this tremendous growth, and our methods for dealing with the projects have not followed the growth. That's the simple answer why we're using outdated methods to do these huge projects, which were inconceivable. We didn't have the hardware and software to do them 10 years ago, 20 years ago, etc. Now, by the way, there's a concurrent thing. Where do people learn their methods? Well, initially they learn them at university, you know, like getting a degree in computer science or something like that. And the fact is our universities have not kept up to date. I mean, ideally, universities would lead and be out ahead of the pack and be teaching things good for the next 10 years. But the universities are not very good at catching up and giving us the tools we need to deal with today's Axon methods and problems. Okay, so we have an education problem together with the technology, which is caused by the speed of technology change. And there are ways of catching up, like read my book. But the university isn't teaching this book. But by the way, some universities are teaching my methods.
Yeah. There's a good example from Norway about that object-oriented programming was invented in Norway with Simula 67.
Yes.
But then the universities decided that industry needs Fortran programmers. So they continued to teach Fortran.
Right.
So Norway could have been like 25 years ahead of the rest of the. I see Mohsen has got his hand up.
By the way, before he goes on, Mohsen, you mentioned object-oriented. By the way, at the I worked together with and taught these initial methods to people like Ole Johan Dahl, who invented Simula 67 and invited me to be a consultant to his project. I was there, we were there. He was the first professor in computer science and I lectured for him at his university. Okay, anyway, Mohsen. Hi.
Hi, thank you for your great talk. I wanted to ask if, is there any architecture roadmap? I want to be an architect and I don't know what the roadmap is. How can I make sure that I will be an architect by reading these books or something like that that you suggest? Thank you.
Yeah. Now, here's the thing. There are, as we know, lots of enterprise architecture certifications, okay? You know, Zachman and Topaz and all the other ones, the ones that were mentioned earlier here. So you can get a certification, but my view is these certifications and these methods are worthless, okay? Now, you cannot get, at the moment, a certification in my methods or anything like them, okay? You can read the book, you can teach yourself, you can do it, okay? But there's a gang out there selling certifications, which in my humble opinion are worthless. They're doing it for Agile and they're doing it for architecture, and it's a mafia racket. And I hope you are not so weak and silly that you fall for it. What you need is real knowledge, what Deming called profound knowledge, that will actually help you do a good job of getting value delivered to your client. And this is kind of tricky. If the universities aren't teaching it and the people with certifications aren't teaching it, you know, how do we know if it's any good? Now, the thing here, and I have a lot of people doing exactly this, if you do this method under the radar, you don't ask permission, you just do it, you will start showing results that are measurable next week and every week, and everybody else will have shown no results and they will have failed, okay? Maybe somebody will get the idea that whatever the heck you're doing works, okay? That's how my methods, in fact, spread. For example, we spread the methods to 20,000 engineers at Intel. It spread because they worked, and one engineer told another, this shit works and we are free to use any method that works. Nobody told us to use some stupid method that doesn't. It's not the Intel culture, okay? Now, if you have, so the fact is, you have to be mature enough to understand that this might work. You have to be courageous enough to try and do it. My friends at Confirmit in Norway, after one day of learning about the method, decided to do it, okay? 1 week they used to do their preliminary study. The next week and every week thereafter for years, they delivered results that were so good that they destroyed their international competition and bought them up, okay? So there's the Norwegian example, Confirmit, of people who just said, they all went to university, NTNU. They were all trained engineers. They never learned any of this stuff, but they did learn engineering thinking. So when they saw engineering thinking they could use on software, they liked it. Same at Intel, same at Hewlett Packard, same at Boeing, same at Ericsson, same at Philips, okay? They recognized that doing this in an engineering manner was smart, but the software people were not teaching them an engineering method, okay? So they did what good engineers do. They tried it out and it worked and it delivered results and they continued using it, okay? Now, if you're in a culture that has no engineers, you're not an engineer, you're surrounded by programmers who believe in things that don't work, you have a problem. Good luck.
Thank you. So which book should I read and by which order? The book,
Okay, now let me, quite simply, this book, the SEA book, here it is. That's the book we're using here. I would say, quite simply, read this book first, and then it points to all the other books. The references at the end give you free access to many other books and papers, okay? So if my recommendation is use the Systems Enterprise Architecture book, this one, as your key book for learning about architecture. There's enough stuff here, it will take you years to absorb and learn all these things. It certainly took me years. Some of my best friends used years, but in one day, 16 smart engineers at Confirmit in Oslo picked up enough to deliver 2 weeks later successful value delivery in their real product. Okay, they didn't get any training course. They did actually use my book and Kai's book called Evo. Okay, so they got our books. We don't know the extent to which they read them, but they had a one-day briefing, which is sort of like a set of these lectures. They had a one-day briefing, and they were smart people, and they just did it. Okay. So most of what you teach yourself will not be by reading books. It will be by trying to do this stuff in practice, okay? And sweating through it. And at some point, if you're persistent enough and smart enough, it will work very nicely. Good results will appear, and you will get support in your working environment from other people who say, like at Intel, teach me that I need it, it works better, you tell me what you did. You will become the teacher, the coach, the consultant for other people. If somebody wants to work out a certification for this, they can, but the essential idea is how it works in practice, not that you passed a stupid exam for a method that actually doesn't work, like most of the agile and enterprise architecture methods I've seen. They are, for me, just a big laugh. They still have failure rates of approximately 40% per project. Look up IT failure rates or IT agile failure rates and see how bad everything is. We don't fail with these methods. We get small failures which are adjusted quickly, and the larger project always succeeds, as at Confirm It and other of my case study places. Oh, gee, 2 more minutes. I hope that sort of answered your question. 2
Yes,
more
thank you.
minutes. Last question. And you all know that you can, I hope you can see my email, tom@gilb.com. I can see it. And so if you have any questions at any time, write me an email, and including requests for things I've talked about and you couldn't figure out where they are in the references. But do look at the reference there. There are at least 50 free downloads of books and papers there. But the core text is this free text system. I wrote this test especially for enterprise architects because I was so angry at the stupid things being taught by the enterprise architects floating around the world holding meetups. Okay, so I hope you will agree at some point when you've had a chance to try things out in practice, you will agree it is better and you will refuse to do anything worse. But I don't expect you to believe me because I say it. You should believe me because you've tried it and it works. That's the test, okay? Not because you got a certificate, not because I held the lecture, because it works for you is all that counts. Okay, we used up our time, and thank you very much. And Thursday, we're going to do risk. Fascinating subject. One quotation is that at Ericsson in Sweden, another engineering company that's used a lot of our methods, we worked for them for 2 years, very successfully. They actually said that risk is the responsibility of absolutely every engineer at every moment of time. Very interesting idea. Risk is in, the devil is in the details, right? So I'm going to teach that idea that absolutely everything you do in every detail has to do with managing risk. And you can read ahead to the chapter or read afterwards and just listen from 4 o'clock next. There we go. Thursday. Thank you very much for me today.
Okay, thanks a lot, Tom.
Okay, thanks a lot.
Thank you for sponsoring this.
So we'll see you on Thursday, and I'll post. There'll be 2 more meetups next week. I'll post them as well.
Thank you. Bye-bye, everybody. Thanks for attending.
Okay, bye.
Bye-bye.